Hello and welcome to yet another video in which we will solve an example of the particular integral of type 1. So we are given a linear differential equation with constant coefficients and the equation is non-homogeneous. As you can see on the left hand side we have got d square y by dx square, which is a second order derivative term, plus 5 times dy by dx, which is the first order derivative term, plus 4y. Well, y is the zeroth derivative of itself. Did you know that? Okay, so this is equal to 4 raised to the power x, right? So the general equation of this, so this is an example of the general equation where we have f dy is equal to a raised to the power x, right? Okay, now first of all we need to identify what is the independent variable and the dependent variable. As you can see in the denominator, it's all x, and on the right hand side the function is purely of x. We will write down that the independent variable is x and the dependent variable is y. So now we write down what is the symbolic form of this equation. So what we do is that we substitute the second order derivative term d square y by dx square by capital D square y. So capital D is basically the differential operator with respect to x, and plus 5 dy, right? Because we have got 5 multiplied by the first order derivative of y with respect to x. So that is 5 times capital Dy plus 4y is equal to 4 to the power x. So what we do is that we extract the y out of it because the differential operator is commutative, is closed under addition and multiplication, right? That's the actual description why we can take the y outside, and that gives us d square plus 5d plus 4 of y as equal to 4 to the power x. So fd is equal to d square plus 4 5d plus 4, right? Now we'll find out the r and also the a, right? So the r is 4 to the power x, right? As you can see in the equation on the right hand side. Now this 4 to the power x can be written as e raised to the power log 4x. How do we do that? Because see, log 4 multiply x is basically x multiplied by log 4, right? So multiplication is commutative, no doubt about that. So x multiplied log 4 is log 4 to the power x. So e to the power log of something is that something whichever we take the log of. So 4 to the power x is e raised to the power log 4 multiplied by x. So the coefficient of x in the power of e is equal to log 4. So a is going to be equal to log 4. Now we have reduced our problem to a type 1 problem, right? Okay, so so that gives us our particular integral as 4 to the power x, that is r, divided by fd, which is 5d square plus 5d plus 4. Now what we do is that we find out what is f of a. Now a is log 4, so we need to find out f of log 4. Now how do we find out the f of log 4? We substitute log 4 in the place of d in fd, and we find out log 4 is equal to log 4 square plus 5 multiplied by log 4 plus 4. Now this particular term is not equal to 0, and how do we claim that? See, 4 is not equal to 0. We obviously know that. Bam. Okay, log 4 whole square. It's a square term. Come on. That cannot be equal to 0. Double bam. Well, and plus 5 multiplied by log 4. Now see, log 4 is greater than log 1. Log 1 is 0, right? So log of anything greater than 1 is a positive number. So 5 multiplied by log 4, that is greater than 0. Triple bam. So log 4 square plus 5 multiplied log 4 plus 4 is not equal to 0. Well, I must give you a disclaimer about the BAM sounds here. This is from a very nice a channel called the StatQuest. I'll put the link in the description for you to go and check out that channel. It's a free shout out to StatQuest. Well, so we have, returning back to our video, we have seen that f of a is not equal to 0, right? So this gives the pi or the particular integral to be 4x divided by f of a, because f of a is not equal to 0. Now we substitute the value of f of a, and that gives us the particular integral as 4 to the power x divided by log 4 whole square plus 5 multiply log 4 plus 4. And that, my friends, is the particular integral for this given problem. Thanks for watching. Come back for more.